Hello students, welcome to today's class. And before starting with our second exercise, that is 2.2, let us discuss exercise 2.1. Now we are very much clear that for a quadratic equation, at the most the number of roots or the solution can be 2, and for the cubic polynomial, at the most the zeros will be 3. It means a cubic equation can have 1, 2 or 3, but at the most 3 means it can have maximum 3 solution. For biquadratic, that is a polynomial with degree 4, we can have at the most 4 solutions. Now let us move to exercise 2.2, and before moving to exercise 2.2, we will be discussing an example in which where we have to factorize a quadratic polynomial, and the quadratic polynomial is x square plus 7x plus 10. So now this is a quadratic polynomial which we have to factorize by splitting the middle term. Now we can relate this polynomial to the identity which we have studied in class 8th, and that identity a plus bx plus ab is equals to x plus a multiplied by x plus b. This we have studied in 8th class. So for factorizing this, we will be splitting the middle term. That means we have to find out a and b which is there in 7. Now how we will proceed? First we have to check whether the polynomial which is given to us is in the descending order of their degree. Here you can see the variable is having a power 2, here 1 and here 0. So the given polynomial is in the standard form, and then we will multiply the coefficient of highest degree, that is x square, and constant. Now on multiplying the coefficient of x square, that is 1, and 10, we get 10, and the factors of 10 are 10 multiplied by 1, and second is 2 multiplied by 5. Now what we have to check? We have to check whether these two factors which we get on multiplying, or sorry, on adding or subtracting, or whether they give 7 or not. So let us see 10 and 1. On adding 10 and 1 we get 11, and on finding the difference of these we get 9, but we require 7x. Now moving to second two factors, second pair of factors. Now here 2 and 5 gives 7, so we will split 7 into 2 and 5. How? Let us see. So we can write 7 as 2x plus 5x plus 10. Now between first two terms, what is common? X. So we will take x as common, and what we are left in first term is x, in second term 2. And between the third and fourth term, 5 is there between both, because 10 is 2 multiplied by 5. So we will take 5 as common and we'll get x plus 2. Now out of 4 terms we have reduced it into 2 terms. Now in these 2 terms again, what is common? X plus 2 and x plus 2. So x plus 2 is common between these 2 terms. So in first term what we are left with is x, and in second term we are left with 5. Now we have to find the zeros of this polynomial. We have to find the zeros of this polynomial. For 0 is a value of x which on substituting it in the polynomial makes polynomial equals to 0. That is, it makes px equals to 0. So for that, what the condition will be? It means that the product of these two will be 0. The product of these two will be 0 if either x plus 2 is equals to 0, or x plus 5 is equals to 0, or both can be 0. Then only we can get 0. For x plus 2 is equals to 0, we get x equals to minus 2, and for x plus 5 equals to 0, we get x equals to minus 5. Now these two values of x, that is minus 2 and minus 5, are called zeros of polynomials. These two are zeros or polynomial and are represented by alpha and beta. We can name this as also beta and this as alpha. That does not make any difference. So alpha and beta are zeros of the polynomial. Now the general form of a quadratic polynomial, and which is ax square plus bx plus c is equals to, as this polynomial give these two as its factor. Now let us suppose the factors are x minus alpha and x minus beta. So how do we get this x minus alpha? Because here you will say these two are having plus between them. Now here we are getting negative. Now we know that's a quadratic polynomial. So on solving this, we will get two zeros. Let the zeros are x equals to alpha and x equals to beta. Now these two are zeros. Now zeros gives factor. How? When you transpose alpha and beta to left hand side. So alpha minus x minus alpha and x minus beta. These are the two factors of this polynomial. So when you multiply these two factors, you will get the polynomial. Same is the case here. These two are zeros. From these two zeros, we get these two factor. When we multiply this factor, we will get our polynomial from where we have started. But what we'll be doing, we will be taking this whole multiplied by k, where k is some constant. Now, why we have taken k as a constant, that I will explain you later. Now let us solve this first. So this will give k, and within bracket it is x square minus alpha x minus beta x plus alpha beta, and when you open the bracket you get kx square minus k alpha x minus k beta x plus k alpha beta. Now these two terms and k also minus k as common, so what we are left with in the bracket is alpha plus beta and x plus k alpha beta. Now our standard equation is ax square plus bx plus c. Now let us compare the coefficients here. The coefficients of x square are that a and it means a equals to k. Coefficient of x are b equals to minus k times alpha plus beta, and constant are, so c is equals to k times alpha beta. So now it means value of k is a, or a is k, and b is minus k times alpha beta, and c is k times alpha beta. So if you substitute the value of k here in b, what you will get, b is equals to minus a alpha plus beta, because k is equals to a. On further solving, we get minus b upon a is equals to alpha plus beta. Similarly here, a is k is equals to a, so a alpha beta, so c upon a is equals to alpha beta. Now this is alpha beta, and alpha and beta are roots of quadratic polynomial. So this whole term is known also called sum of roots, whereas this term is called product of roots. So these are sum of roots and this is product of root. So what do we get from it? We get that sum of roots, that is alpha plus beta, is equals to minus b upon a. Now what is b and what is a? B is a coefficient of x and a is a coefficient of x square, and alpha beta, that is product of root, is c upon a, where c is a constant and a again is a coefficient of x square. Ax square plus bx plus c is equals to kx square minus k. Alpha beta means sum of roots plus k times product of roots. So quadratic polynomial, if sum and product of if the roots are given to you, you can easily write the quadratic polynomial by using this formula, where it is k times x square minus k times sum of the roots x plus k times product of the root. Now what is the function of k here? Now let us take our first example again. The first example was this. Now let me multiply this whole equation by 2. So let us see what do I get. 2x square plus 14x plus 20. So on multiplying the whole equation by 2, I get this. So now what the factors of this will be? 2x square. Now coefficient of x square is 2 and 20, this is 40. And 40 factors of 40, 1 into 40, 2 into 20, 4 into 10, or 5 into 8. So here in this we get 14 as a sum. So plus 4x plus 10x plus 20. Now between first two terms 2x is common, so x plus 2. Between second two terms 10 is common, so x plus 2. Between these two x plus 2 is common, so 2x plus 10. So again, because on multiplying these we get 0, so from here x equals to minus 2, and from this 2x plus 10 equals to 0, 2x equals to minus 10, so x equals to minus 10 upon 2, that is minus 5. So it does not make any difference when you multiply this whole polynomial with some value constant, that is 2. Now if you multiply by 3, 4, 5, so the roots will always remain same. So now why we have taken k here? Because if we would have not taken k here, then the value of a will gives you 1, which will not be the case in all the problems. In some problem you might be having k equals to 1, but we have represented by k where k is not equals to 0, it's some other value, and it shows that k is not always 1, it can have any value. Now moving to our exercise 2.2, and what the first question says is, the first question is, find the zeros of the following polynomial and verify the relation between zeros and the coefficients. So the first question of exercise 2.1 is, where first we have to factorize the given polynomial and find its roots. So let us solve this. Coefficient of x square is 1 and the constant is minus 8. On multiplying this I get minus 8. So factors can be 1 into minus 8 or minus 1 into 8. Second, 2 into minus 4 or minus 2 into 4. So which can be used to split the middle term, that is minus 2. So this will be equal to x square. So on adding this we get 7, and on subtracting we get minus 9, but we require minus 2. So here on adding you get minus 2, here on getting you get plus 2. So these two are the required one. So plus 2x minus 4x minus 8. So what is there common between first two are x. So x plus 2 is common. We are left with, now between these two what is common? Minus 4. So minus is outside, plus now, and here also minus is outside, we are left with plus and 2. Now between these two terms x plus 2 is common. So from first term we are having x, and from second term we are having minus 4. We have to find the zero. That means on multiplying we have to find the value of x which gives this polynomial equals to 0. This shows either x plus 2 equals to 0 or x minus 4 equals to 0. Now if x plus 2 equals to 0, then x equals to minus 2, and if this equals to 0, then x equals to 4. Now this I will represent as alpha and this as beta. Hence the roots of the quadratic polynomial are minus 2 and 4. Now we have to verify the relation between the coefficients and the zeros, and this is a relation, that is alpha plus beta is equals to minus b upon a, and alpha beta is equals to c upon a. So first is alpha plus beta is equals to minus b upon a, and alpha beta is equals to c upon a. Now from the equation we have a equals to 1 because coefficient of x square is 1, b equals to minus 2 because coefficient of x is minus 2, and c equals to minus 8. So let us substitute the value here. Alpha is minus 2, beta is 4, minus because it is there in the identity, beta b is minus 2, and a is 1. On solving this, 2 equals to 2. So our result is verified. This is correct. Now let us check it for product of the roots. Alpha is minus 2, beta is 4, c is minus 8, and a is 1. So on multiplying these we get minus 8, which is equals to minus 8, and this is also verified. This is how you have to verify. I will be doing one more. So it is in the form a square minus b square. This will give a minus b and a plus b. So t square is the square of t, and 15 is the square of root 15. So we get t minus root 15, t plus root 15. So either t minus root 15 is equals to 0 or t plus root 15 is equals to 0. So we get t is equals to square root of 15 and t is equals to minus square root of 15. So this is our alpha and this is beta. Now let us verify the relation, and the relationship is alpha plus beta is equals to minus b upon a, and alpha beta is equals to c upon a. Now that for that we have to find the coefficient a, b and c. Let us again go to the equation, that is t square minus 15. So highest degree, then t to the power 1 is not there, but we have added it here, and 15. So if you put t here, the equation, the polynomial given to you will change, and this will alter the answer. But we have substituted the t here, so that we will take the coefficient as 0. So from this our a will be 1 because coefficient of t square is 1. Our b will be 0 and c will be minus 15. Now let us verify. Alpha is square root of 15, beta is minus square root of 15, minus b is 0 and a is 1. On solving this, so sum of the root is verified, and the product is root 15 multiplied by minus square root of 15 is equals to c, that is minus 15, and a, that is 1. So on multiplying this we get plus into minus minus, and root 15 will give 15, which is equals to 15. So hence it is. We will do question number 2, exercise 2.2, and question number 2 statement is find the quadratic polynomial each with the given numbers as sum and product of its zeros respectively. So sum and the product of the roots are given. Now question number 2, first part, sum of the roots is equals to 1 upon 4, whereas product of the root is minus 1. Now what the sum of the root is? Sum of the root is equals to alpha plus beta, which is equals to minus b upon a, and product of the root, that is alpha beta, is equals to c upon a. Now alpha plus beta, it is given to you, that is 1 upon 4, which is equals to minus b upon a, and alpha into beta minus 1 is equals to c upon a. Now if you compare these two fractions, here minus b upon a is equals to 1 upon 4. So because these two are equal, fractions are equal, it means we can say b is equals to minus b is equals to 1 and a is equals to 4. So if a is equals to 4, from first relation we get value of a is 4. Whereas if you compare these two fraction, for product of the roots, we are getting minus 1 upon 1, we can say, is equals to c upon a. It gives value of a is equals to 1. So we have to make this, either we can change it to 1, that will be difficult, but for making this 1 equals to 4 will be easier. We will multiply numerator and denominator by 4. So we get, so because fractions are equal, so we can compare. Now minus b is equals to 1. So minus b is equals to 1. So b is equals to minus 1. A equals to 4. So a equals to 4. And again here minus 4 equals to c. Therefore c is equals to minus 4. So c is equals to, here I will write minus 4. But we have to write the quadratic polynomial for it, and the general form of quadratic polynomial is ax square plus bx plus c. So what is a here? 4x square. What is b here? Minus 1, so minus x. And what c is? Minus 4. So this is a required quadratic polynomial. Thank you.